So in Module 5, we're going to be extending our work with forces. So we're going to be using our problem-solving skills that we've developed in the last module, the approach where we're defining our system, we are drawing our forces, we are summing the forces to figure out what the acceleration is. All of those things are going to apply. We're just adding new forces now and new types of motion. So one of those new forces that we're going to be dealing with is the concept of friction. And now there's two different kinds of friction that can act on an object. One is static friction and the other is kinetic friction. Static friction is what keeps your tires on the ground and what propels your car forward. So to get your car to move forward, your engine is causing your tires to rotate, which is applying a force on the ground, and then the ground is applying a force on your tires, propelling the car forward. And so that force from the ground is the force of static friction. In this GIF that I have here, it's showing what happens when the road gets wet. So you may have heard that, you're supposed to slow down whenever the road is wet from a rainstorm. And why is that? So the key is that we have this quantity called the coefficient of friction. We have it for static friction and for kinetic friction. So when it rains, the coefficient tells you how smooth or how rough a surface is. So when it rains, you can think of it as, instead of just asphalt now, we have a layer of water molecules on top. And those layer of water molecules have a lower coefficient of friction because they're smoother than the asphalt is. So if the coefficient decreases, that means the frictional force decreases. And if that frictional force decreases, that means you can't have as much force coming from your engine. You can't rotate your tires too fast, or the static friction can't keep up. And at that point, that's when your car starts to slide. So the car, this truck is going around the bend. It's keep maintaining its speed, but since the ground is wet, the coefficient of friction is smaller, and it can't keep the tires going in the right direction. So as the truck starts to slide, we're transitioning from this static friction into kinetic friction. Because the difference between static friction and kinetic friction is that one moves relative to the surface and the other does not. Kinetic friction, your object needs to move relative to the surface. So as you're going along, as you're driving along, the point on your tire and the point on the ground don't move relative to each other. But as the truck starts to slide, now the point on the ground and the point on the tire are moving relative to each other, and you're turning into kinetic friction. So we're going to get a lot more practice on this as we move forward. The other instance where you get static friction is, say, if you're trying to move a heavy piece of furniture. You're pushing on the furniture, say like a couch on a carpet floor. You're pushing on it, but it's not going anywhere. You're applying a force, so something must be opposing that force to make the couch not move. And so that force is the force of static friction between the couch's legs and the carpet floor. And so that static friction can increase up until a certain point where your friction or your applied force overcomes the static frictional force. So static frictional force can be anything up to some maximum value. Then once you reach that maximum value, and the object starts to slide, or the couch starts to slide, you turn into kinetic friction at that point. Let's take a look at that idea real fast, because it's a little weird. So what we have here, this is a PhET simulation from the University of Colorado. And so we've got friction and we've got this mass, and I'm going to apply a force on it. And so let's see if it moves. So I'm applying a force now. The block is not moving, but I have an applied force. So there must be the frictional force acting in the opposite direction, which is this left arrow. And so it's balancing. What if I increase my force? Is it going to move? Take a second to think. Well, it really depends on what the mass of the block is and what the coefficient of friction is. So let's see. I've increased my force, and the force of static friction has increased, but the block's still not moving. So this is one of the things about static friction is you can keep increasing a force up to a certain point. Frictional force, the static frictional force, doesn't have to be the maximum value. It can be anything to oppose the motion up until its maximum point. So let's add a little more force and let's see what happens. Here we go. So we've reached the maximum static frictional force. We've overtaken it. And now the block starts to move because we have a net force in the right direction. And now this type of frictional force, this is no longer static frictional force now. Once the object starts to move relative to the surface, we are now in kinetic friction and not static friction. The other type of motion that we're going to be looking at and forces that we're going to be looking at is the concepts around circular motion. So with circular motion, the acceleration is always pointing towards the center of the circular motion. The velocity is always going to be tangent to the direction of the acceleration, which is pointing inwards. And so we have circular motion all around us. So that is dealing with planets going circular around other planets. For our case, the moon's going around the Earth. Satellites are orbiting around the Earth. We're orbiting around the sun. For roller coaster rides and any kind of amusement park rides where there's an arc, that's going to be described using circular motion. And that's how you design roller coaster rides, taking into account the physics principles and using circular motion to describe what kind of accelerations are the riders going to experience, because you don't want to have too large of an acceleration or you end up passing out. Another example of circular motion is with sports. So here's a hammer throw in track and field. The ball is moving around in the circle. The girl throwing has to exert a force inward to keep that ball in that circular path. So she's having to counter the ball. Another, I don't have a picture of it here, but centrifuges in biology and chemistry, they get used a lot to prepare samples. They're spinning around samples very fast in a circle. And what it's allowing you to do is it's exerting a force on the sample to separate out the components that you want of your sample. So circular motion's all around us. And then here are the learning objectives. Again, we're going to be going through circular motion, static friction, and kinetic friction. And just like last module, we're going to be using free body diagrams and Newton's second law to describe what's happening physically using mathematics.